Determine whether the geometric series converges or diverges, and if it converges, find the sum. So here is our complex geometric series. Our common ratio is 2i over 2 plus I. We have 2i over 2 plus I to the k. And a geometric series converges if the modulus of the common ratio is less than 1. So it looks just like the condition for a real series, except instead of absolute value of the common ratio, it's the modulus of the common ratio. So what is the modulus of our common ratio? The modulus of a fraction is the modulus of the numerator divided by the modulus of the denominator. And the modulus of 2i is 2. The modulus of 2 plus I is the square root of 2 squared plus 1 squared. And so we have 2 over the square root of 5. And 2 is the square root of 4, which is less than the square root of 5. And so this fraction is indeed less than 1. And so therefore the series does converge. Now what is the sum? The sum of a geometric series of the form c to the k starting from 0 to infinity, is 1 over 1 minus c. So in our case, our sum is 1 over, we have exactly that form. K starts at 0, 0 to infinity, c to the k, where c is the common ratio. So the sum is 1 over 1 minus, and then we have to put here 2i over 2 plus I. And now we'll simplify this, 1 over, and then in order to subtract here, we need a common denominator, 2 plus I. And so this is 2 plus I minus 2I, 2 plus I minus 2I over 2 plus I, which is 1 over, and here we have plus I minus 2I is 2 minus I over 2 plus I. So the sum is 2 plus I over 2 minus I. I guess we could write that in standard form. If we multiply by 2 plus I, the conjugate of the denominator, over itself, then on the bottom we get a real number, which would just be 5. And in the numerator we get 4 minus 1, so 3. And then the imaginary part will be 2i, 2i, so 4i. So it looks like our sum is 3 plus 4i over 5, or 3/5 plus 4/5 I.